Okay, so think about it. In the cloud, you've got all your secure, private data, and then you've got, well, the entire internet. The big challenge, right, is how do you connect the two without letting all that chaos come flooding in? Well, today, we're going to build the exact gateway that makes this possible. Let's get right into it. So here's the game plan. First, we're going to build our own digital fortress. Then we'll look at two different ways to get aligned to the outside world, a public front door and a super secure back door. We'll even see how the modern way stacks up against the old school do-it-yourself method. And then, at the end, we'll put all the pieces together and look at the complete master blueprint. All right, so this really gets to the heart of the problem we're tackling today. Just imagine you've got this super secure server, right? It's holding really sensitive data. It absolutely needs to go out and get the latest software updates from the internet, but here's the catch. You cannot, under any circumstances, let anyone from the internet start a conversation back with that server. So how in the world do you build that perfect one-way street? Okay, to even begin to solve this puzzle, we have to start by building a secure foundation. It's all about carving out our own little corner of the cloud where we are in complete and total control. And that foundation? It's called a virtual private cloud, or a VPC for short. You know, the best way to picture it is like your very own private office building, just digital, floating in the cloud. You are the building manager. You control every single door, who gets in, who gets out, and everything that happens inside. It's your turf. And right there, that brings us to this fundamental tension, this balancing act you find in all of cloud networking. On one hand, you need total isolation for security. But on the other, you need connectivity so your apps can actually do something. You know, get updates, talk to other services, serve your users. It's this constant tug of war between total lockdown and open access. Now think back to our office building. You wouldn't just have one gigantic open floor for everybody, right? Of course not. You'd have different departments, different floors. And that's exactly what you do with your VPC. You divide it into what are called subnets. These are just partitions that let you group your resources together. Kind of like the accounting department on one floor and sales on another, each with its own set of rules and security. And these subnets, they really come in two main flavors. First, you've got your public subnet. Think of this as the lobby of your office building. It's designed to face the public and interact with the outside world. But then you've got the private subnet. These are like the secure keycard-only offices way in the back. There's absolutely no direct path from the street to get into these rooms. And that, of course, is exactly where you're going to stash your most critical, sensitive data. Okay, so we've got our public lobby. Now, how do we actually connect it to the internet? Well, you can't just knock a hole in the wall. You need a very specific, highly controlled main entrance. And that main entrance is called an Internet Gateway, or IGW. It's basically a highly available, ready-to-go component that you just attach to your VPC. Its whole job is to handle all that two-way traffic for your public-facing stuff. It really is the official, big, shiny front door to your entire cloud building. And you know what? Setting one up is surprisingly simple. It's pretty much 3 steps. You create the gateway itself, you hook it up to your VPC, and then you just update the directions for your public subnet. It's called a route table, to basically say, hey, anything that wants to go to the internet, send it out through this main door. That's it. All right, cool. So that takes care of our public lobby. But this brings us right back to that big, critical question we started with. An internet gateway is a two-way door. You can't just point your super secure private offices at it. That would defeat the whole purpose. So, how do those guys get out to download their security patches? For this job, we need a completely different kind of door. We need a special, secure exit. One that, and this is key, only opens in one direction, out. And this is where the NAT gateway comes in. NAT stands for Network Address Translation, and honestly, it's the magical key to solving this whole problem. It lets all the computers in your private subnet start a conversation out to the internet, but, and this is the beautiful part, it completely blocks any random connection from the internet from ever getting in. I love this analogy. Think of a NAT gateway like a really good company receptionist. Your private server, safe in its office, can ask the receptionist, hey, can you call this update server for me? The receptionist makes the call. When the update server calls back, the receptionist knows exactly which internal office to send that information to. But what happens when some random cold caller on the internet dials the main number? The receptionist politely says, sorry, I can't connect you. It is such a brilliant and simple solution for security.
And don't think for a second that this is some tiny, flimsy backdoor. Oh no. A single NAT gateway is an absolute beast. It can handle up to 55,000 simultaneous connections to a single place. I mean, that's some serious firepower. We're talking enterprise-grade, secure outbound access.
So the NAT gateway, that's the modern, slick, managed solution we have today. But, to really appreciate just how good it is, it's worth taking a quick peek at the old do-it-yourself way that it replaced. See, before NAT gateways were a thing, you had to build what was called a NAT instance. You literally had to set up your own server just to do this one job. And the difference between the two, it's night and day. A managed NAT gateway is highly available right out of the box. With an instance, you had to figure out what to do if it failed. The gateway scales its bandwidth up and down automatically, and instance's bandwidth was totally fixed. And the biggest one, the cloud provider takes care of the gateway. With an instance, you were the one on the hook for all the patching, all the updates, all the headaches. So yeah, the official recommendation on this is crystal clear. For pretty much any situation you can think of, the managed NAT gateway is just plain better. It's more available, it has more bandwidth, and it's way less work for you. It's a total no-brainer, the clear winner. Okay, so let's zoom out and put all of these pieces together. What does that complete picture look like? How do we finally achieve that perfect, delicate balance between security and connectivity? Here it is. This is the blueprint. It all starts with the VPC. That's your private fortress. Then, for anything public-facing, the stuff in your lobby, you use that two-way internet gateway. And for all your really important private resources tucked away in those secure offices, you give them a NAT gateway. That's their secure, one-way exit to the world. So the really crucial takeaway here is that it's not about picking just one of these tools. It's about how you combine them. It's the strategic use of all these components together that gives you that incredible fine-grained control over who can talk to what. And honestly, this architecture right here, this is what lets companies build the secure, massive, powerful apps that really are the backbone of the modern internet. And with that, we're at the end of our explainer. We've seen exactly how to solve a really common but really critical networking puzzle. But, as technology keeps racing forward and our digital lives get even more tangled up with our physical ones, it kind of leaves you with one last thing to think about, doesn't it? What's the next big challenge just over the horizon? And what will be the next NAT gateway that comes along to solve it? Thanks so much for joining me.